So today's crash course is on mole concept and stoichiometry. Okay, our agenda today, we will go through the 4 mole formulas. Okay, then we'll go through stoichiometry, and there'll be 2 questions that I'll go through as well. Then after that, limiting reagent, percentage priority, and percentage yield. Okay, so 5 key components today, right? Then at the end, there'll be a Kahoot quiz, so y'all can try. And there'll be some questions that are not that are different also. Okay, and then at the end there's a feedback form. So I'm doing this crash course for free, right? This 1 hour 30-minute crash course for free. So all I ask in return is to do the feedback form at the end, okay, so that we can improve. Is that all right with everyone? If it's all right, please give me a reaction or thumbs up. All right, then let's begin. So we'll start with the 4 mole formulas. Okay, so the first mole formula is 1 mole equals to 6 times 10 to the power of 23 particles. So what exactly does this mean? 6 times 10 to the power of 23. This is called Avogadro's constant. Okay, which means 1 mole of any substance is equivalent to 6 times 10 to the power of 23 particles. Okay, so it's a lot of particles. There's a lot of zeros. There's 23 zeros in total. Okay, and then particles can mean many things, right? So for our syllabus, we learn 4 things. Okay, it can mean atoms, it can mean molecules, it can mean ions, and it also can mean electrons. Okay, these 4 things. So for example, if I were to say 1 mole of sodium will be equivalent to 6 times 10 to the power of 23 of sodium atoms. Okay, then if I were to talk about molecules, maybe 1 mole of carbon dioxide molecules equals to 6 times 10 to the power of 23 of carbon dioxide molecules. Okay, then 1 mole of silver ions equals to 6 times 10 to the power of 23 silver ions. And same thing for electrons. 1 mole of electron equals to 6 times 10 to the power of 23 of electrons. Okay, so 1 mole of whatever substance, right, equals to 6 times 10 to the power of 23 of that particle. Okay, so that's mole formula 1. Hold on. Let me accept people in. Okay. So different particles, they might have different number of moles. So if you have 3 moles, it will just be 3 times 6 times 10 to the power of 23. Okay, which is the same as 18 times 10 to the power of 23 particles. Okay, so if the question asks you what is the number of particles of a certain substance, first you need to find the number of moles. Okay, then once you know the number of moles, you just multiply it by 6 times 10 to the power of 23 to get this number of particles. Okay, so 3 moles of something equals to 18 times 10 to the power of 23 of particles. Okay, then again, particles can be atoms, molecules, ions, or electrons. Right. So usually this mole formula is very rarely tested, but it's still important to keep in mind. All right. Second mole formula. Number of moles equals to mass in grams divided by the MR, which is the molar mass. Okay. So the MR of substances can be found in the periodic table. Okay. So whenever they give you a known substance, that means like carbon dioxide, any substance that is known, you can find the MR using the periodic table. Okay, so it's all the bigger numbers in the periodic table that is the MR. All right, the molecular mass. So if they give you the mass of a known substance, immediately you should know that you can find the number of moles. All right. For example, they give you the mass of oxygen. So maybe 32 grams of oxygen. Okay, then immediately you should know that you can find the number of moles of oxygen. Okay, because they give you the mass of a known substance. So how do I find the number of moles? I take the mass of oxygen in grams divided by the MR. Okay, so the mass will be 32. The mass will be 32. Then what is the MR? Oxygen, it exists as O2, right? It's a diatomic molecule, O2. So if I look at the periodic table, oxygen has a, sorry, let me change the color. Oxygen has an atomic mass of 16, right? But there are two oxygen atoms, so I have to use 16 times 2. Okay. So it will be 32 divided by 32 to give me 1 mole. All right. So 32 grams of oxygen is equivalent to 1 mole of oxygen. Okay. So that is the second mole formula, mass in grams divided by MR. Okay, so MR is the relative molecular mass. Right. Then we move on to the third mole. Okay, I forgot to mention something important. So for this mole formula, right, you can use it for any substance in any state. Okay, so it doesn't matter solid, liquid, gas, or aqueous. You can use this formula for all state. All right. Now for mole formula 3, we have number of moles equals to volume of gas divided by 24 dm cube. Okay, you realize I wrote it very specifically, volume of gas. So what does that mean? That means this formula can only be used for gases. Okay, this formula only used for gases at room temperature and pressure. That means all gases at room temperature and pressure will take up 24 dm cube of volume. Okay, that's what this formula is trying to say. All gases will take up, sorry, for every 1 mole of gas in room temperature and pressure, it will take up 24 dm cube. Okay, so 2 moles, it will take up 48 and so on. So only use this formula for gases. And important note, you need to ensure that the volume of gas is in dm cube. Okay, so maybe a question will give you 500 cm cube of hydrogen. Okay, then you need to find the number of moles, right? Do you take 500 divided by 24 to find the number of moles? No, you don't do that. You have to change cm cube to dm cube. All right, so 1 dm cube is equivalent to 1000 cm cube. So to change 500 cm cube to dm cube, I will need to divide by 1000, right? So 500 divided by 1000, I'll get 0.5 dm cube. Okay, so 0.5 dm cube will be the volume of hydrogen. Okay, so how do I find number of moles? I just divide it by 24. Okay, so moles of hydrogen, 0.5 divided by 24. Okay, then if you put it in your calculator, you'll get this value. Okay. So the key point here is only use this formula for gases. So if they give you a volume of a gas, you know immediately, I can find the number of moles because I just need to divide by 24 dm cube. Okay, and then these are only for gases at room temperature and pressure. Okay, and ensure that the units are always the same when you are dividing. So you have to, if you want to divide by 24 dm cube, make sure that the volume of gas is also in dm cube. All right. So that's mole formula 3. Only use it for gases. Okay. Mole formula 4, we have number of moles equals to volume times concentration. Okay. So only use this formula for solutions. So solutions are basically substances dissolved in water. Okay, this is a solution. When a substance dissolves in water, it forms a aqueous solution. So that is a solution. So usually they give you the volume and concentration. Okay, then what you want to do is multiply them together in order to find the number of moles. Okay, and when you multiply them together, you need to make sure that the units are these units. Okay, dm cube and mole per dm cube. All right. Okay. So the volume of the solvent which is usually water, is in dm cube. Okay, the volume is in dm cube. Then the concentration equals to amount of solute in the given amount of volume. So the solute is what dissolves. The solute dissolves in the solvent. And then your solvent is usually water. It will dissolve the solute. Okay. So concentration is how much solute is there inside a solvent. The higher the concentration, the more solute it is inside a given amount of solvent. And the lower the concentration, the less amount of solute in a given amount of solvent. Okay. So for this mole formula is only used for solutions. Okay. Volume times concentration. All right. So I put these four formulas together so you guys can refer to it easily. All right, then I'll move on to stoichiometry. So this is the important part. This stoichiometry is how we apply the mole formulas into the paper. Okay. So stoichiometry shows the relationship between the quantities of substances in a chemical reaction using a balanced chemical equation. Okay. So from a balanced chemical equation, we can see the relationship between all the quantities. For example, in this reaction, right, calcium carbonate reacting with hydrochloric acid. From this reaction, we know that 1 mole of calcium carbonate reacts with 2 moles of hydrochloric acid to give 1 mole of calcium chloride, 1 mole of carbon dioxide, and 1 mole of water. Okay, so you have 1 mole, 2 mole, 1 mole, 1 mole, 1 mole. This is showing the relationship between the quantities. That means this amount react with this amount to give this amount. Okay, showing the exact quantities in the reaction. Okay, so for stoichiometry, there are 4 steps. Okay, and I remember this using the 4 C's. Okay, so these are the 4 C's. First, you convert the quantities into mole. Okay, so the question will throw at you different quantities, but don't get confused. Immediately, you just convert them into mole. Okay, convert them into number of moles. Then the second step will be to write the chemical equation. Okay, they'll give you different substances, but you want to write the chemical equation so that you can see the relationship between the quantities. And then the third step, once you can see the relationship, you compare the mole ratio. Okay, compare the mole ratio, which means the substance where you found the number of moles, you use it to compare with another substance. So you know what is the number of moles of every substance. Okay, then finally you can calculate the final amount, which is usually what the question is asking for. Okay, so I'm not going to use this example here. I'm going to use the one below. Okay, so aqueous sodium chloride can be prepared by titrating aqueous sodium hydroxide with dilute hydrochloric acid. The equation for this reaction is shown below. So we have sodium hydroxide plus HCl to give me NaCl plus H2O. Okay, this is the chemical reaction. So in this titration, 50 cm cube of 0.50 mole per dm cube sodium hydroxide was used. Calculate the volume of 1.5 mole per dm cube hydrochloric acid needed to neutralize the alkali. So whenever I see a mole question, right, first thing I do is step 1, convert quantities into moles. So whenever you don't know what to do when you see a mole question, you just want to see what are the quantities they give you. So in this scenario, I already found 3 quantities. We have 50 cm cube, 0.5 mole per dm cube, and 1.5 mole per dm cube. Okay, then I will highlight what type of quantities they are. So this is volume, this is concentration, and this is also concentration. So just from looking at this, I can actually use one of the mole formulas to find the number of moles already. Okay, So in this case, I got volume and concentration of sodium hydroxide. And if you recall, mole formula for number of moles equals to volume times concentration. Okay, and it's for solution. So I'm gonna do step 1 here, which is converting the quantities into mole. Okay, so I can find the number of moles of sodium hydroxide, which is 50 over 1000 times 0.5. Okay, so I didn't just take 50 times 0.50. Can anyone tell me why I divided by 1000? So why 50 divided by 1000? Okay, can you please write down in the chat? Why did I divide by 1000 instead of just 50 times 0.5? Okay, why is it 50 divided by 1000 times 0.5? Correct, to change from cm cube to dm cube. Okay, good job. So 50 divided by 1000 will give me the volume of sodium hydroxide in dm cube. Okay, in dm cube. Then this is the number of this is the concentration. Okay, so if I put it in my calculator, I'll get 0.025 mole. Okay, so this is the number of moles of sodium hydroxide used. Okay, second step, chemical equation. So in this case, they actually did it for us already. So the question is very kind. They already wrote the chemical equation for us. But in some scenarios, we do have to write ourselves up. But since they done it for us already, we can skip to step 3, compare the mole ratio. Okay, so when you're comparing mole ratio, it's always between two things. Okay, two substances. So what do we compare in this case? We compare NaOH with hydrochloric acid. Okay. How do I know which two things to compare? First, you want to use the substance where you found the number of moles. Okay, I found the number of moles of sodium hydroxide. So I'm definitely going to use it to compare mole ratio. Then why did I choose HCl, hydrochloric acid, to compare? Because that's what the question wants. The question asks, calculate the volume of this amount of hydrochloric acid. Okay, calculate the volume of 1.5 mole per dm cube hydrochloric acid needed to neutralize the alkali. So since they want me to find hydrochloric acid, then I compare with hydrochloric acid. Okay. So the mole ratio is basically from the chemical equation. Based on the equation, the mole ratio between NaOH and HCl is 1 to 1. Okay. 1 to 1. All right, then now we can find the actual number of moles of HCl. So we know for NaOH is 0.025. So if we compare it, it is also 0.025. Okay, because 1 to 1. Okay, it's the same. So number of moles of HCl used is 0.025. That is step 3, compare mole ratio. Now that you have done comparing the mole ratio, you can finally calculate the final amount, which is usually what the question is asking for. So they want me to calculate the volume of 1.5 mole per dm cube hydrochloric acid. Okay. So they gave me concentration, they gave me the number, I found the number of moles. So this is mole formula 4. Okay, mole formula 4. Number of moles equals volume times concentration. But now I'm not finding number of moles. Now I'm finding volume. So how should I change the formula such that it is correct? I like to use this method, which is I draw a triangle. Then I draw a T in the middle. Okay. Then for mole formula 4, the top of the triangle will be mole. This will be volume. This will be concentration. So by drawing this triangle, no matter which is the subject, I know how to flip the formula. That means, right, if I want to find number of moles, I take volume times concentration. Okay, because they are beside each other. If I want to find concentration, I take mole divided by volume. Okay, because mole is on top of volume, right? Then if I want to find volume, I take mole divided by concentration. Okay, now I want to find volume, so I have to take the mole divided by concentration. What is the mole of hydrochloric acid? We found it just now, right? 0.025. Okay. And what is the concentration? They gave it to us actually, 1.5. Okay, they gave it over here at the question A. So volume will be 0.025 divided by 1.5 to give me 0.0 cm cube. Okay, so I put my answers to 3SF always. All right, I'll let you guys copy this down. Okay, can we use 16.7 cm cube instead? Yes, you can. You can convert it. As long as the question doesn't say leave your answer in dm cube or leave your answer in cm cube, then you can convert it. How do I know if I should leave the answer in cm cube or dm cube? If the question didn't ask, they will accept both. Okay, but if the question asks specifically leave your answer in dm cube, then you leave it in dm cube. Then if the question asks leave your answer in cm cube, then you leave it in cm cube. But if it didn't ask, you just leave it as whichever you like. Okay, does that answer your question? Both of your questions? Okay, then let's move on to part B. Calculate the mass of sodium chloride form. Okay, so let's look at the 4 C's again. I'm gonna bring it down here. Okay, first step, convert quantities into moles. We already did that in the first step. Okay, so we don't have to do that again. Second step, chemical equation. Okay, we already have the chemical equation down. So we can move on straight away to the third step. Compare the mole ratio. So now this time we need to understand which mole ratio to compare to. First one is definitely NaOH, because it's the first thing that we found, the number of moles of. Okay. Then I'm going to compare it with sodium chloride. Why sodium chloride? Because they want us to calculate the mass of sodium chloride form. Okay, if they want us to calculate mass of sodium chloride form, I should be comparing mole ratio with sodium chloride. Right? So if we look at the equation, 1 mole NaOH to NaCl, it is 1 to 1 also. Okay. So this is quite a simple example. All the mole ratio is 1 to 1. But if the mole ratio is like 2 to 1, then you all can just divide by 2 to convert. Okay. All right. So for NaCl, once I compare the mole ratio, I know that the actual number of moles is 0.025. Okay, then we can move on to step 4. Calculate final amount. What do I want to calculate? Mass of sodium chloride. Here again, I use the triangle method to know how the formula should be flipped about. Okay. Okay, so if I scroll up, right, this will be mole formula 2 because I'm finding mass. Okay, mass. So if I want to find mass, okay, so number of moles equals to mass over mR, right? So I'm going to write it in the triangle first. Number of moles equals to mass divided by molar mass. Okay, so if I want to find mass, it will be moles times mR. It will be mole times mR. Okay, so we found the number of moles of NaCl, which is 0.025. Then the mR, we can use the periodic table. So for Na sodium, it is 23, and then for chlorine is 35.5. Okay, so you all can just refer to the periodic table for this. So 23 plus 35.5. Okay, then just put it into the calculator. Sorry, not divide, sorry. multiply 1.46 grams, okay, to 3SF. So we always leave everything to 3SF, 1.46 grams. Right. So any questions for this first question? If no questions, you can give me a thumbs up. If not, I want you guys to try question 2. I'll give you all 2 minutes. Since the answer is exact, do I still need to give it in 3SF? Usually it's better to give it in 3SF. But if your teacher say exact answer don't need, then you can follow what your teacher says. Yeah, but I don't think you'll be deducted if you don't give it in 3SF because it's an exact answer. Yeah. Okay, I'll go through question 2 now. So the formula of an oxide of element Y is Y2O3. Okay, this formula. And then Y is an unknown element. Okay, this unknown. So 8 grams of Y2O3 contains 5.6 grams of Y. How many moles of Y does 5.6 grams of the element contain? So they want to find number of moles of Y. Okay. Let's look at the quantities they gave us. So remember first step. First step is to convert quantities into mole. So they gave us 8 grams of Y2O3 and 5.6 grams of Y. But at this moment, right, we actually cannot convert anything into mole because Y is an unknown element, which means that we cannot find it in the periodic table yet. Okay, so even though they gave us the mass, we cannot divide it by the MR because we don't know what is Y. But something we can do is, we know oxygen, right? So we can actually find the mass of oxygen. Because 8 grams of this oxide contains this amount of Y, that means the remaining amount is oxygen. Okay, so the mass of oxygen is 8 grams minus 5.6. So 2.4 grams. This is the mass of oxygen. Okay, and now that we have the mass of oxygen, we can find number of moles. Okay, because oxygen can be found in the periodic table, and the number of moles is 16. Sorry, the MR is 16. Okay, so using mole formula 2, mole equals to mass divided by MR. Okay, mass divided by MR. So mass is 2.4, MR is 16. Okay, this is the number of moles of oxygen. But the question asks, how many moles of Y does 5.6 gram of the element contain? So they want to know the number of moles of Y. Okay, so what we can do is actually compare the mole ratio. Okay. Third step, compare mole ratio. In this case, we cannot write the chemical equation because there's no chemical equation to write. But what we can do is compare the mole ratio. So the compound is Y2O3, right? Y2O3. So the mole ratio is 2 to 3. Okay, 2 to 3. And then we know that oxygen is 2.4 divided by 16, right? So to convert from 3 to 2, how to convert from 3 to 2? I will have to multiply by 2 over 3, right? 3 times 2 over 3 will give me 2. Okay, so most of Y is actually 2.4 divided by 16 multiplied by 2 over 3. That will be the number of moles of Y. Okay, which means your answer is A, 2.4 over 16 times 2 over 3. Okay, now I'll be moving on to limiting reagent. So limiting reagent is the reactant which is used up completely in a chemical reaction. Okay, it's used up completely in a chemical reaction. So when it's used up completely, the whole chemical reaction will stop. Okay, because it's completely used up. So there's nothing more to react. So the chemical reaction will stop. So it will cause the other reactant to become in excess. Okay, so you have two substances, right? Once one is completely used up, the other reactant will become in excess. So let me use this analogy. Let me draw a simple hamburger. Okay. So in order to make one burger, I need 2 buns and I need 1 patty. Okay. I need 2 buns and I need one patty to make this hamburger. So what is the chemical equation? It will be 1 patty plus 2 buns to give me 1 burger. Okay, this is the chemical equation of burger. Let's say I have 10 patties and 30 buns, right? How many burgers can I make? Can you guys comment down in the chat? How many burgers can I make with 10 patties and 30 buns? 10, right? Okay. So when I make 10 burgers, I will use up 10 patties and I will use up 20 buns, right? Because the mole ratio is 1 to 2. The mole ratio between patty and buns is 1 to 2. So if I use 10 patties, I have to use 20 buns. But I have 30. So I'll have excess, right? I will have 10 remaining. Because I have 30 buns, I only use 20. So I have 10 remaining. So the one that is remaining is the one in excess. Okay, so the buns are in excess and the patties are the limiting reagent. Okay, the buns are in excess and the patties are limiting reagent. Why? Because the limiting reagent is completely used up, right? When I react the patties and the buns, the 10 patties are completely used up, whereas I still have 10 buns remaining. Okay, so the patties are the limiting reagent. Okay, so if we bring this to chemistry, right? Let's look at the example. Magnesium burns in hydrogen gas to form magnesium hydride. Okay, so this is the chemical reaction. Mg plus H2 give you MgH2. Right? If 4.8 grams of magnesium is mixed with 0.2 grams of hydrogen, determine the limiting reagent. Okay. So first I will have to find the number of moles for both of them. Okay. So number of moles of magnesium, I can use mass divided by MR. Okay, because they give me the mass and I know that magnesium is from the periodic table. Okay, it's a known substance. So the MR of magnesium is 24. So to find the number of moles for magnesium, it is 4.8 divided by 24, which will give me 0.2 moles. Okay. Then now I have to find the number of moles of 0.2 grams of hydrogen. So 0.2 grams of hydrogen, I take 0.2 divided by 2. Okay, because MR of hydrogen is 1, but we have 2 hydrogen atoms, so I divide by 2, therefore giving me 0.1 mole. All right. 0.1. So let's look at this. The mole ratio between magnesium and hydrogen is 1 to 1. Okay, if we look at the chemical equation, 1 magnesium reacts with 1 hydrogen to give me 1 mole of MgH2. Okay, so the mole ratio is 1 to 1, but what is given? What is given is 0.2 and 0.1. Okay, so from this, we can find the limiting reagent. So if I use 0.2 moles of magnesium and 0.1 mole of hydrogen, and I react them together, I will have 0.1 mole of magnesium in excess. Okay, because the mole ratio is 1 to 1. So 0.1 mole of hydrogen will react with 0.1 mole of magnesium. Therefore, for magnesium, I will have excess remaining. But hydrogen is completely used up, right? So hydrogen is a limiting reagent. So your final sentence is hydrogen is the limiting reagent because it reacts completely in the reaction. Okay, keyword reacts completely. That is what a limiting reagent is. Okay, then let me give you guys a tip, exam tip, okay? If the question gives you two quantities where you can find two number of mole, that means they give you two different substances and they give you the quantities of the substances such that you can find the number of moles. So in the end, you can find two number of moles of two different substances. Then most likely it's testing you on limiting reagent. Okay. So if you can find the mole of substance A and you can find the mole of substance B, then usually they want you to compare and see which one is excess, which one is limiting. Okay, so that's just a tip. Let me write it down. If you can find more of A and more B. So A and B is just a random example. If you can find more of A and more of B, usually it's testing you on limiting reagent. Okay. So if you have to find the mole of two substances, then usually it's testing your limiting reagent. Okay, give you 4 minutes to try question 3. So in a reacting flask, 500 cm cube of hydrogen is mixed with 500 cm cube of oxygen and is ignited. Okay. So which reactant is the limiting reagent? Okay, remember the first step, convert quantities into mole. Okay, that's the first step. So I'm going to convert all the quantities into mole. So these are volume of gases, right? So I can use mole formula 3. Okay, mole formula 3 is number of moles equals to volume of gas divided by 24 dm cube. Right. So I'm going to change all the cm cube to dm cube by dividing by 1000. Okay, so 500 divided by 1000 will be 0.5 dm cube. And this one is the same. Okay, now that I've converted, I can find the number of moles. So moles of hydrogen, 0.5 divided by 24, which is 0.020833. Okay. So usually for intermediate step, right, I'll leave my answer to 5SF. Okay, so that I have more accurate values to work with. And then moles of oxygen equals to same thing, 0.5 divided by 24 equals to, okay, again to 5SF. So both of them have the same number of moles. Okay, what's the second step for stoichiometry? Second step is to write the chemical equation. So this is the chemical equation. We have 2 moles of hydrogen reacting with 1 mole of oxygen to give me 2 moles of water, H2O. Right. So what's the third step? Third step is to compare mole ratio. Okay, this is the third C, compare mole ratio. Okay, so what am I going to be comparing? I have to compare hydrogen and oxygen. Okay. So based on the chemical equation, the actual mole ratio is 2. 2 is to 1. Right. And then what is given? For what is given is 0.020833 to 0.020833. Okay. So which is the limiting reagent in this case? Okay, let's say I use up this hydrogen 0.020833, right? Then for oxygen, I'll only be using half of it, right? Because the mole ratio is 2 to 1. So if I use 0.0208 for hydrogen, I will use 0.01 something for oxygen. Okay. So the main point is, after using all the hydrogen, I will have excess oxygen remaining. Okay. And for hydrogen, therefore will be the limiting reagent. Okay. Because all the hydrogen is used up. All hydrogen is used up, whereas I have excess oxygen remaining. Okay. So in my final statement, hydrogen is the limiting reagent as it is used up completely. Okay, hydrogen is the limiting reagent because it is used up completely. After the reaction, there will still be excess oxygen remaining, so hydrogen is the limiting reagent. When do you use RTP and when do you divide by MR? So if they give you the mass of a certain substance, then you know you can divide it by the MR to find number of moles. Okay, and for mass, right, it can be any type of substance. It can be solid, liquid, gas, or aqueous. Okay. Then RTP, I assuming you are talking about volume of gas. So when do you use volume of gas in room temperature and pressure? When they give you a gas. Okay, when they give you a gas or when they give you the volume of a gas. Okay, that's when you use. Okay. So for MR, it's through the mass. And for RTP, is through the volume of gas. Okay, does that answer your question? Divided by 24 by mass. Oh. Yeah, so if they give you cm cube of a gas, it has to be a gas in room temperature and pressure. Then you can change it to dm cube, then divide by 24. Then if they give you a mass of a substance, you just divide by the molar mass. Okay, can you explain how to write the equation again? So basically hydrogen and oxygen, it will give you water, correct? Then from there, you just have to balance the equation. Okay, so originally it was H2 and O2, and then you get H2O. But to balance, we need the same number of atoms and the left side on the right side. Okay, so let me write the originally it was like that. Okay, so how do I balance? On the left side, I have two H atoms and two oxygen atoms. Okay, then on the right side, I have two H atoms and one oxygen atom. Okay, so hydrogen atoms are already balanced, so I just have to balance the oxygen. Okay, but if I add 2 over here, I have to add 4 here, which doesn't make sense, right? So I add 2 to hydrogen. Okay, so now it's 2 times 2. Now it's 4 hydrogen atoms here. Then for this one, I have to add 2 also to balance it out. But for this, if I add 2, here will be 4, and here will be 2. So that's how everything is balanced. Can you explain why hydrogen is the limiting reagent and not oxygen? Okay, can. So focus on the mole ratio part now. What is the mole ratio between hydrogen and oxygen? It's 2 to 1, correct? 2 to 1. Based on the chemical equation, which is 2H2 plus O2 to give you 2H2O. Okay, so it's 2 to 1. But what is given to me? What is given to me is 0.0208 moles of hydrogen and 0.0208 moles of oxygen. Okay, so this is how the equation will look like if I actually use everything. Once I use this amount of hydrogen, right, I will have to use half the amount of oxygen, right? Because the mole ratio is 2 to 1. So how much oxygen will be used? I will divide by 2. This is the amount of oxygen used. Okay, only 0.01 mole of oxygen is being used. Therefore, oxygen will be in excess, whereas hydrogen is completely used up already. All this hydrogen will be reacted away, so it will be gone. So if it's gone, it's the limiting reagent. Then if it's in excess, it's the excess reagent. Okay. So does that answer your question, Yu Tong? Okay, calculate the mass of water from. Okay, now we know that hydrogen is the limiting reagent, so we're going to use the number of moles of hydrogen. Okay, we choose the limiting reagent to compare mole ratio. Why? Because it is the one that is being completely used up. So it's the most reliable way to compare mole ratio. Okay, so we're going to compare mole ratio between hydrogen and H2O. So hydrogen is, okay, we look at the chemical equation. 2 is to 2. All right, so in simpler terms, it's 1 is to 1. And the actual mole of hydrogen is 0.020833. Okay, this 5-digit decimal. Okay, so 1 is to 1. So number of moles of water will be 0.020833. Okay, this is the number of moles of water. Then from the number of moles of water, in order to find the mass of water formed, which mole formula should I use? Keyword, mass of water. If we're finding mass, there's only one mole formula to use, which is mole formula 2, right? Moles equals to mass divided by mR. So mass equals to mole times mR. Okay. If we look at a triangle, right? Look at this triangle here. Mass equals to moles times mR. Okay. So what is the number of moles of water? 0.020833. Okay. And then what is the mR? For hydrogen is 1. So it's 1 times 2 because there are 2 hydrogen atoms. Then for oxygen is 16. Okay. So put this into your calculator. 0.375. Okay, so this is the mass of water. All right, if there's no questions, I will move on to percentage purity. So the formula for percentage purity is the actual mass used. So the actual mass used or the actual mass reacted in the reaction divided by the total mass. Okay, then to find percentage times 100%. So for example, if you have an orange juice, right? So you have a bottle of orange juice, and then the label, usually you see those labels saying 80% pure juice. Okay, which means out of the 100% of orange juice, 80% of it is pure orange juice. Okay, then the other remaining percent, the other 20% is probably water or food coloring. Okay, it's probably water, food coloring, or other additional stuff. Okay. So in chemistry, we know this as impurities. And then the pure juice will be the useful substance. Okay, either the useful substance or the actual amount used. Right. So for example, 6 grams of carbon burns in air and produces 15 grams of carbon dioxide. Determine the percentage purity of carbon. Okay. That means they want you to determine what is the actual amount of carbon reacted. Then I can find the percentage purity. So first I find the number of moles of carbon dioxide. Okay. When it comes to percentage purity or percentage yield, you always want to find the number of moles of the substance that is already produced. Okay. So in this case, carbon is the reactant, and then carbon dioxide is the product. Always find the number of moles of product. Okay. Find more of this. Find more of the product. So the product is carbon dioxide. So I'll take 15 grams divided by the MR to get 0.3409. Okay, so how do I find MR of carbon dioxide? Carbon dioxide is CO2, correct? So carbon is 12, O is 16. So 12 plus 16 times 2 will give you 44. Okay, and then 15 is the mass of carbon dioxide. So I'll get 0.3409 mole. This is the number of moles of carbon dioxide. Okay, then now I compare the mole ratio. Wait, sorry, now is the chemical equation. So the chemical equation is carbon plus oxygen to give me CO2. Okay, that's the second step. Then finally, the third step is to compare mole ratio. So I'm going to compare the mole ratio of carbon dioxide and carbon. Based on the chemical equation is 1 to 1. Okay, then based on the actual amount is 0.3409. So for carbon, it will be 0.3409 mole. Okay, so this is the actual moles of carbon. Remember, they give you 6 grams of carbon to react, right? But actual moles is 0.3409 mole. Okay, so now I can find the actual mass of carbon reacted. So mole equals to mass divided by mR, correct? That means mass equals to mole Mass is moles times MR. Okay. What is the mole of carbon? 3409. Then what is the MR of carbon? It is 12. Okay. So in order to find the mass, 0.3409 times 12. Okay, it'll give me 4.09 grams. So what does this 4.09 grams represent? It represents the actual mass of carbon reactor. Okay, so 4.09 grams is the actual mass of carbon reactor. But what is the mass of carbon given? The total mass, 6 grams, right? 6 grams is the total mass of the carbon sample. But the actual mass reactor is 4.09 grams. Okay, now we can apply the formula, which is actual mass used divided by total mass of the sample. Actual mass used is 4.09. Okay, 4.09 grams divided by the total mass, which is 6 grams. Okay, then I times 100% to give me 68.2. Okay, 68.2%. So 68.2% is the percentage purity of carbon, which means the other 30% could be impurities. Okay, right. So I'm going to give you guys 4 minutes again to attempt question 4. 0.6 grams of a piece of impure magnesium ribbon was dropped into a conical flask containing excess dilute hydrochloric acid. So 480 cm cube of hydrogen gas was evolved. Okay. The reaction also produced magnesium chloride. Write the equation for this reaction. So the equation, okay, this is your equation. So make sure you balance the equation properly. So your your hydrochloric acid will have 2 moles. Okay, then the rest is 1 mole. This is your balance equation. Okay, then part B, calculate the percentage purity of the, I forgot to mention, this equation is actually what we learned, which is acid plus metal reaction. Okay, so acid plus metal, remember, what will it give you? It will give you salt plus hydrogen. Okay, so this acid is hydrochloric acid, and then the metal is magnesium, and the salt is magnesium chloride, and hydrogen is hydrogen. Right, so this is your acid plus metal reaction. All right, part B, calculate the percentage purity of the magnesium ribbon. So again, I'm going to calculate the mole of the product. What is the product in this case? Hydrogen gas. Now, which formula should I use? They give me the volume of hydrogen gas, right? So I'm going to use mole formula 3. Number of moles equals to volume of gas divided by 24. So first I convert cm cube to dm cube. So the volume will be 0.4. Okay, I'll take 480 divided by 1000. So I get 0.48 dm cube of hydrogen gas. And this will be the amount that I divide by 24. Okay, so 0.48 dm cube divided by 24 dm cube. Then you put it in your calculator, 0.02. Okay, so 0.02 moles of hydrogen. Now we compare mole ratio. Okay, compare with which one? Compare with magnesium, because the question is asking for the percentage purity of magnesium. So if we look at the chemical equation, the mole ratio is 1 to 1. Okay, then the actual mole will be 0.02 mole to 0.02 mole as well. Okay, so now we know the actual number of moles of magnesium. We can use it to find the mass of magnesium. Why do I find mass of magnesium? Because this question is asking percentage purity. Percentage purity is actual mass over total mass times 100%. Okay, so I need to find the actual mass of magnesium now. Okay, let me be more specific, actual mass. And again, using the formula, mass over MR. Okay, so it will be 0.4 mole times mR of magnesium. What's the mR of magnesium? It is 24. Zero point 0.48. Okay, so this is the actual mass of magnesium. Now I look at the original mass. Original mass is 0.60. Okay, so I can compare it and actually find the percentage purity. Okay, percentage purity is actual mass. What's the actual mass of magnesium? 0.48 grams divided by the total mass of the sample, and the sample is 0.6 grams. Okay, times 100%. So your answer is 80%. Okay. If not, I move on to percentage U. So percentage U is very similar to percentage purity actually. It's actual U divided by theoretical U to give me, times 100%. Okay, so this percentage U. So for example, right, a recipe in a cookbook. If I follow this recipe, I should get 20 cookies. But I tried this recipe and I only managed to get 15 cookies. Okay, because some of the dough was stuck in the pan. Okay, some dough was stuck. So this is a good example of actual U versus theoretical U. If I follow the recipe in the cookbook, theoretically I should get 20 cookies, right? That's the theoretical U. But I only got 15 cookies. Okay, because of some mistakes. Some dough was stuck into the pan. I didn't do it properly. So this is the actual U that I got. Okay, so this is a theoretical U and actual U. So in order to find the percentage U, I will take 15, which is theoretical, divided by 20, which is 15, which is the actual, divided by 20, which is the theoretical, times 100%. Okay, so the percentage U of the cookies is 75%. Right. For example, in a displacement reaction, 15 grams of iron powder was added to excess copper 2 sulfate solution. Okay, a mass of 9.50 grams of copper was found to form in the reaction. Calculate the percentage U of copper metal. Okay, again, right, you want to find the number of moles, find the mole of the reactant. Okay, so product was for percentage purity. For percentage U, you find the number of moles of the reactant. Okay, so 15 grams of iron, you can find the number of moles using mass divided by MR. Okay, so 15 divided by 56. 56 is because the MR of iron is 56. Okay, I'll get 0.2679 mole. Okay, then the second step is to write the chemical equation. So Fe plus CuSO4 will give me FeSO4 plus Cu. Okay, so this is your displacement reaction. Okay, iron will displace copper inside copper 2 sulfate. So I will get iron 2 sulfate and copper. Okay. Then you compare mole ratio. So I compare mole ratio between iron and copper. Based on the chemical equation is 1 to 1. So for iron, since the actual mole is 0.2679, for copper it will also be 0.2679. Okay. So 0.2679 mole of copper is produced. That means the theoretical U will be, you can find the theoretical U now. Okay. We are given, now we know the number of moles of copper. So we can find the theoretical U, which is the theoretical mass of copper formed. So it will be the number of mole 0.2679 times the MR. What is the MR of copper? It is 64. Okay, so I do this, multiply together, I'll get 17.1 grams. So this is the theoretical U. This is what you expect to get. Okay, 17.1 grams of copper. But what is the actual U? Actual U is 9.5. So I take actual U divided by theoretical U to give me 55.6%. Okay. Actual U divided by theoretical U, 17.1 to give me 55.6. So 55.6% is the percentage yield of copper. Right. So can you guys try question 5? Okay. There are 3 parts to this question. I'll give you. Okay, we don't have much time left, so I'll just give 5 minutes. 5 minutes, then I'll go through. Okay, maybe, yeah, 5 minutes. Some elements burn in air to form oxides. In an experiment, burning sodium was held in a flask containing a solution of red limus. At the end of the experiment, the product of the reaction dissolves in the solution. Okay. So I already mentioned some elements burn in air to form oxides. So the mass of sodium at the start of the first experiment was 0.50 grams. Calculate the theoretical yield of sodium oxide. So what is the yield that you expect to get from sodium oxide? Okay. First, I can find the number of moles of sodium. Okay. Because they give me the mass. So the mass, I can use it to divide by MR. Okay, to find the number of moles. So mass of sodium is 0.5. MR of sodium is 23. Okay, from the periodic table. So I'll get 0.021739. Okay, I'll keep it to 5SF. Okay, then second step is to write the equation. So if you manage to balance it correctly, you should get 4Na plus O2 to give you 2Na2O. Okay, 4, 1, and 2. That should be the balance equation. Right. The next step, to find the theoretical U, we have to compare the mole ratio. So I'm going to compare sodium. I'm going to compare sodium to sodium oxide. So it will be 4 to 2. Okay, and then in simpler form is 2:1. So the actual mole of sodium is 0.021739, which brings the actual mole of sodium oxide to be that divided by 2. Okay, because the mole ratio is 2:1, so I have to divide by 2. And this is the number of moles I got. Okay, to 5SF. So I'm using 5SF so that I can have more accurate calculations. Right now, I know the number of mole of sodium oxide. I can find the theoretical U, or basically the mass. It will be mole times MR. Okay, what is the MR of sodium oxide? We have 2Na, so it will be 23 times 2. And we have 1 oxygen, so it's 16. Right? So I put this in the calculator, 0.674 grams. Okay, this is the theoretical yield or the theoretical mass of sodium oxide, 0.674 grams. Okay, I'll be moving on quickly for this one. So the table below shows the mass of the flask and indicator before and after the experiment. So before, 94.50 grams. Okay, this is the mass of the flask and the indicator and everything. Then the flask and the contents at the end is 94.82. So there is an increase in the mass. And what exactly caused the increase? It is the formation of sodium oxide, correct? In this reaction, sodium oxide is formed, and then what? The product of the reaction dissolves in the solution. So it dissolves over here. So that's why it's added to the weight. Okay. So I can find the mass of sodium oxide, the actual mass, actual U. Basically be 94.82 minus 94.50. Okay. So 0.32 grams. 0.32 grams. Okay. So this is the actual U. And I have the theoretical U, right, which is 0.674. So I just pull in the formula of percentage U, which is actual divided by theoretical times 100%. then you should get 47.5%. Okay, 47.5% to 3SF. Okay, so this is the percentage yield of sodium oxide. Chemical equation was wrong. Yeah, so it's very important to write the correct chemical equation, and also very important to balance it. Suggest a reason why the percentage yield is not 100%. Okay, why is the percentage yield not 100%? Usually it's because there are impurities, right? There are different impurities that react with oxygen to form oxides. And what happened to these oxides? They are gas, right? So it will actually escape into the atmosphere. Okay, so this is the full answer. So the sodium used may contain impurities, and these impurities will burn in air, or it will react with the oxygen in the air to form gaseous oxides. Okay, then because they are gaseous oxides, they will escape into the atmosphere. That's why the mass of sodium oxide produced is lower than expected. Okay, I'll give you guys 1 minute to copy all this. And then afterwards is the Kahoot quiz. Okay, let's begin. True or false? Okay, so 12 people mostly got it correct. So 1 dm cube equals to 1000 cm cube. Okay, so the first question is just a test. Now we start counting points. Which of the following is the correct formula for calculating number of moles? Okay, the questions will get progressively harder. Okay, mostly got it correct. So moles equals to mass divided by molar mass. All right, Keston, good job. What volume in dm cube is occupied by 2 moles of SO2 gas at room temperature and pressure? Wow, moles put 24. Okay, because there's 2 moles of SO2, 1 mole occupies 24 dm cube. So 2 moles will occupy 48 dm cube. Okay. All right, good job. What is the molar mass of carbon dioxide? So you guys need to prepare your calculator with you. Good job. Mostly got it correct. Keston still leading. Okay. How many moles of NaCl is formed? Okay, I gave you the equation as well. Okay, so this question is actually all about mole ratio, right? The mole ratio between sodium and sodium chloride is 2 to 2. Okay, so in simpler form is 1 to 1. So since it's 1 to 1, if 0.5 mole of sodium reacts with chlorine, I'll get 0.5 moles of sodium chloride. Okay, because 1 to 1. So 0.5 to 0.5. Okay. Jing En is now leading. What is the total number of atoms in 1 mole of water? Think carefully before you answer. Okay, so still mostly got it correct. In 1 mole of water, there are 2 hydrogen atoms and 1 oxygen atom. So total 3 atoms. Okay, and for every 1 mole of atom is 6 times 10 to the power of 23. So 3 moles will be 6 times 3, 18. 18 times 10 to the power of 23. Okay. Gaston is back in the lead. What is the total number of water molecules in 1 mole of water? Okay, now they're asking for water molecules. Okay, so in 1 mole of water, there's only 1 water molecule, so it's 6 times 10 to the power of 23. Okay. The limiting reagent. When 4 moles react with 4 moles of hydrogen, 3 moles of oxygen, right? So the mole ratio originally from the chemical reaction is 2 to 1. Okay, 2 to 1. So 4 moles of hydrogen will react with 2 moles of oxygen. Okay, but I'm given 3 moles of oxygen. So since I'm given 3 moles, I will still be left with 1 mole of oxygen after the reaction is done. So this is in excess. Oxygen is in excess, but hydrogen is completely used up. Okay, so hydrogen is the limiting reagent. Okay, Gaston still in the lead, and then CCH is climbing up. Which sample of gas occupies the smallest volume? Oh, you guys are answering very fast. Okay. So, wait. Wait, did I put the answer wrongly? Two smallest. Okay, so for smallest volume, right? Okay, never mind. The answer is correct. For smallest volume is basically the smallest number of moles lah. So for hydrogen, the number of mole will be 4 divided by 2, which is 2 moles. For ammonia is 34 divided by 14 plus 3, which is also 2 moles. Okay, so 1 mole of a gas will occupy 24 dm cube. So the lesser the mole, the lesser the volume. Then for carbon dioxide is 1 mole. Okay, then oxygen is 1.5 mole. So since carbon dioxide occupies the least number of, since carbon dioxide has the least number of moles, it occupies the smallest volume. Okay, because 1 mole is 24 dm cube of space. Okay, all gases is like that. So the lesser the mole, the lesser the volume. Okay, good job, CCH. Final question. You have 1 minute 30 seconds to try this question. Yeah, I was confused about the question line. It's an interesting question. I'll actually go through this question in the below. Okay, 5 of you got it correct. So I'm going to explain why the answer is 50% after this Kahoot. Okay, third place, Singan, good job. PH second place. Who is our winner? Good job, Keston. Okay, I'm gonna stop this. So this was the question. 50 grams of impure calcium carbonate reacts with excess HCl, forming 6 dm cube of CO2 at room temperature and pressure. Okay, so for percentage purity, I always want to count the number of moles of the product. What is the product here? CO2, carbon dioxide. So moles of CO2. Okay, I'm given 6 dm cube of CO2. Okay, so that's the volume of gas. So number of moles equals to volume of gas divided by 24. So 6 divided by 24 is 0.25 mole. Okay. Then now I compare the mole ratio. So I compare between CO2 and calcium carbonate. It's actually 1 to 1. Okay, based on the chemical equation, 1 mole of ACO3 and 1 mole of CO2. Right. Then what's the actual mole of CO2? 0.25 moles, correct? So for calcium carbonate is 0.25 moles as well. So now I find the mass of calcium carbonate. So this is the actual mass, which is 0.25 times. Okay, I gave you the MR of calcium carbonate, which is 100. So for mass, you just take the mole times the MR, 0.25 times 100 to get 25 grams. And then your final answer, to find the purity of limestone, the purity of calcium carbonate times 100%. Okay, which is 50%. All right, so that's why your answer is 50%. If there's no questions, right, can you guys please fill up this feedback form? Okay.